I will start recording, and we will go through the solutions to this test, question by question. All right. So Bob is arranging 6 colored blocks in a row. There are 3 identical green, 1 red, 1 blue, and 1 yellow. The total number of possible arrangements of the 6 blocks is. So we have math. Okay. Sorry, should have had this prepped. Okay, so we have, let's run through this again. So we have 3 identical green blocks, right? 1, 2, 3. Pretend they're identical. 1 red, 1 blue, 1 yellow. So red, blue, yellow. So how many ways can we rearrange these? Well, we could start by thinking, well, this is a permutation of 6, right? 6p6, or that's the same as 6 factorial, except we're told the green are identical. So we have to divide by 3 factorial for the green. So that is 720 over 6, or 120.
When I got 120 for three answers, I was like, yo, I think I'm doing something wrong now. 120 for 3 answers. I was like, what?
All right, so any questions about this one in class or online? Okay. Kulnur? Yes, no? All right. So here, a new model of car is available in 5 colors, 3 different engine types, and with 4 different option packages. How many different types of this car are available? And here we don't even have to do the numbers, we just have to recognize what the approach is. This is a fundamental counting principle option. I see the answer in the chat there. That's the correct one. Yeah, 5 times 3 times 4. So there are 60 options, but we don't need to get to the 60. We just need the 5, 3, 4. So how many 5-digit natural numbers can you create using only the digits 0, 1, 2, 3, and 4 if no digits can be used more than once? So this one, this is a 2-case problem. Because if it has to be a 5-digit number, you have to have or actually it's not a 2-case problem, but the key is that the first digit, you only have 4 options because you're not allowed to use the 0. Then it's no longer a 5-digit number.
Oh my god. I actually accidentally did 4 at the start. Then I could have got the answer right. Accidentally.
Yeah. So after you say, okay, now for the rest, 0s and options, there's 4 options left, 3, 2, and 1. So this is 4 times 4 factorial, which is 4 times 24, which gets us to the 96 that was provided in the chat. Any questions about this one?
Trick question.
Not a trick question, one we did multiple examples of in class. Specifically saying that, yeah, you can't start with 0. It was the same problem as saying, add n-digit even number. And that's why we had the 2 cases, because you could end with a 0 or not. All right, so this one. Another classifications problem. So dialing a 10-digit phone number with distinct digits. So yeah, order matters. There's a huge difference between phoning 191 and phoning 911.
That's exactly what I thought when I was doing the question. Exactly my example.
Okay. All right, so now, okay, we've got a couple solutions in the chat here. Choosing 5 people for a committee. Yeah, that's a combination. The word choose is usually a giveaway for a combination. Selecting 4 fruits to put in a salad. Yep, that's a combination. And opening a lock with a 3-number code. Yes, because again, if order doesn't matter, your security is terrible. All right, and another pathways problem. So we have 1, 2, 3, 4, 5, 6, 7, 8 blocks to go east, and 1, 2, 3, 4, 5 blocks to go down. I'm going to calculate the number of possible routes that Jill can take to get to Jack's house if she only travels south and east. 2, 3, 4, 5, 6, 7, 8 here, 5 here. So we're really permuting 8 easts and 5 souths. So that is 8 plus 5 factorial over 8 factorial 5 factorial. Yeah. So which, mathematically speaking, is actually the same as 13 choose 5. It's like you have 13 directions, you pick which 5 of them are south. And because of the symmetry, that's the same as 13 choose 8. So a little bit of calculator work there. There's 1,287. Any questions about this one? Okay. All right. The number of 3-letter arrangements that can be made from the word baker is... So what is this? Is this fundamental counting principle? Is this permutation, or is this combination?
As combination. It's supposed to be 20, but most of it is 1 point. It was supposed to be 6C3, but we did 6P3.
Yeah, this one should be 6P3.
6P3?
Or 5P3. Because there's 5 letters in the word baker.
Oh, no, I was looking at the numeric quantity.
Because the letter arrangements, we do care about the order of letters in the word.
Oh, it's 5P3? Oh, we did 5 permutation over 3 permutation. I'm sorry, 5 factorial over 3 factorial.
Yeah, we have 5 letters to pick from, and we're arranging just 3 of them. So of those 5, we permute 3. 5P3 is 60.
Oh, wow. Wouldn't it be combinations? Since it doesn't matter which letters we put.
So, but it's a 3-letter arrangement of the words, right?
Yeah.
So is the word R the same word as era?
Yeah. I mean, it's the same words, or the same letters,
But if you look up these 2 in the dictionary, are you going to have the same definition?
No, but like...
So that's what makes them different.
But there's be words that don't even have a definition as well, right?
Right, but all they care about are the letter arrangements. So it does the order of letters. When you're rearranging letters, the order will always matter. Oh, sorry. Were there any other questions about this one before we move on? All right. Number 4. A hotel offers free breakfast and has 3 different kinds of juice, 4 different kinds of cereal, and 2 different types of pastries available. If Tim must choose 1 kind of juice, 1 type of cereal, and 1 type of pastry, how many different possible breakfasts can be ordered? Yep, this is the fundamental counting principle. So 3 times 4 times 2 makes 24. So any questions about this one?
Until this point, this question's pretty good. Except for that one question, which we did.
Okay. So we've got some Reveille playing here. Okay. So this one, 6 distinct points are on the circumference of a circle as shown. Triangles can be formed by connecting any 3 points. The number of different triangles that can be formed using this 6 points is. So let's actually do this with the GeoGebra Oh, I don't want the calculator, sweet. Sorry.
So you did permutation for the smart wall, right?
Yeah. Sorry, I wanted to switch calculator. There we go. Geometry.
Geometry.
So let's take that. So that's our circle. Right? And we have 1, 3. So there's 6 points on the circumference somewhere. So let's say we're going to make as our triangle out of points C or A or B, E, and G. Right? So these two, just to make it easier to draw. Is this going to be a permutation or a combination? Yeah, because we can go B, E, then G, and it makes this triangle.
Or it's the same if we go a G.
We can, yeah, GBE makes the same triangle.
Pain.
EBG makes the same triangle. EGB. Right. So for all of these permutations of these three letters, we have one triangle. So all that matters is the combination of points, not the permutation. So this is 6C3.
Yeah. I know my explanation order does not matter. If one point replaces the other, it will be the same. Here's the definition for a combination and row order does not matter.
Yeah. So that's why it's 20. So again, the most popular or common mistake on this was to treat it as a permutation. And then you get 120. All right. Any other questions about this one? All right. So, from 6 dancers and 8 singers, how many performing groups of 4 can be selected if there must be 2 singers or 2 dancers and 2 singers in the group?
No, sorry. 6C2 times 8C2.
Yes, you choose 2 from one group and you choose 2 from the other. So yes, in this randomization, it's A. So, okay. Any questions about this one? So, this is very similar to an in-class example we did. North American area codes are 3 numbers. Before 1995, area codes had the following restrictions. First digit could not be 0 or 8. Second digit was either 0 or 1. And the third digit could be any number from 1 through 9 inclusively. So this is actually a simpler one than the example we did in class, where you were not allowed to have another 1 after the 1 for things like 811 and 911. So this is a bit of a simplification. So what approach is this? Is this fundamental counting principle? Is it permutations or combinations? Yeah, it is the fundamental counting principle. How many choices do we have for the first digit?
8.
We have 8. How many for the second?
2.
And how many for the third?
9.
Yeah.
144.
So 8 times 2 times 9 is 144.
You're doing these with the questions, this feels so good.
All right. And the last question on the test. So Abdul collects hockey cards. He has cards of 30 different players, 5 goalies, 10 defensemen, and 15 forwards. The number of ways he can select 1 goalie, 2 defensemen, and 3 forwards to give his friend who is starting a collection is what? Yeah. So let's break it down step by step. So of the 5 goalies, we're choosing 1. So he's choosing one of the 5 goalies, and he is choosing 2 of the 10 defensemen, and 3 of the 15. Yeah. Yeah. If you do 3C15, your calculator won't like it. Yeah.
5.
Sorry. Yes. So there are. That's a 5, and
Times 45 times 457.
No, we should say 5 times 4, 5 times 4, 5, 5.
Whatever.
Because we have to flow.
4,
5, 5, 5.
yeah. So yeah, there is a little bit of a pattern there, but which actually makes me wonder: does the pattern continue? 20C4 is 4845.
Yes.
So anyway, so we have 5 times 45 times 455, and yeah, that gives us C, 102,375.
Spain, but the S is 5.
So, any questions about this before we submit and see how we did?
No.
There we go.
I think the most challenging question was the one that's we couldn't start with the 0. And I think we just forgot that.
Yeah.
The rest of them were easy.
Permutation.
The rest of them were the easiest questions. And next one's set theory and game theory, which is pain.
So, well, we still the next one is the second probability. There's 2 probability
Also,
units.
we're doing game theory and set theory after that?
Yeah.
Oh, this is not next. Okay.
No, that's unit 6.
Oh, okay.
So unit 5, which we will start on Monday, we'll be dealing with odds and probabilities, mutually exclusive and non-mutually exclusive events, and with independent and dependent events.